Hello everyone, my name is Pingren and I'm a software engineer at AI. I'm honored speaking to you today about hosting GPU-Powered Jina AI Flows on GCP VMs. For those not familiar with AI, we are a platform providing millions of AI-generated art pieces and easy-to-use tools to create your own. As you may have noticed, my profile picture on the event poster was generated using AI. The event organizer asked me to provide some of my pictures, and I don't have a good one, so I just use AI to create them. This one and this one. It's just one of the examples of amazing things that can be done by AI. If you are interested, feel free to check it out at openart.ai by yourself. Let me talk a few questions about this talk before diving into the topic directly.
So who would be interested in this talk? This talk is for developers who have limited or no experience with cloud platforms, such as GCP and AWS. I will provide simple code and cloud infrastructure examples. So don't worry if you have never deployed an AI service before. I will also share demo code on my GitHub, so you can easily try it out for yourself. I am still learning GCP and cloud-native technology. If you are experts and find this talk too easy, please accept my apologies in advance. What are benefits of hosting flows with GPU on GCP VMs? First, it's relatively simple to create and manage cloud VMs with GPUs compared to other options such as Kubernetes. Second, you can quickly test your GPU workflows on a VM, which allows you to gain instant feedback and make adjustments as needed. This is very useful when you don't have access to a high-performance GPU in your development machine. Third, GCP can assist in scaling up your AI services with just a few clicks. This allows you to take your experiments and quickly turn them into production-ready services. Now, let's dive into code and demo. Feel free to ask questions at any time in the chat. In this section, I will set up the VM and run the service. Let's go to the Google Cloud dashboard for Compute Engine. You can get into here by using the search bar. And if you are the first time to use this service, it may ask you to enable the API. You need to set up a billing account for Google Cloud. It should give you some free credits to play around. Now, let's create a VM by click Create Instance button here. And we choose a T4 GPU. It is the most affordable GPU option on GCP. We will keep the minimum CPU and memory settings. And we will change the image. We will use the deep learning on Linux image. This is a series of images provided by Google Cloud. Don't forget to change the version with PyTorch CUDA support. To allow external HTTP requests, we will configure firewall settings here. Now we can create the VM. It takes some time to create a VM. In the meantime, let me introduce today's demo project. The demo is a simple Jina flow with a simple executor. The executor loads a pre-trained model from a research by UC Berkeley. It basically takes an image and a prompt, and it will return the modified image for you. Let me run the code on my local machine and see if it works. And I provide a test HTML. Open it to test the service. The image URL is an image of Mona Lisa. And let's use the prompt, make her wear sunglasses. Let's click submit. And we can see the original image on the left side. Okay. Modified image on the right side. Not too bad. Now let's go back to our VM. We can connect to it by clicking button here, or we can view the Google Cloud command. We can use the command in our favorite terminal. If we ask to install the NVIDIA drivers, we type yes. So once it's installed, we don't need to worry about graphic cards or CUDA support. It just works. And now we will check our GPU. So we have a working GPU here. Let's clean up the terminal. We git clone to pull the project. And we enter a project and install its dependencies. It takes some time to install dependencies. I will cut the video. After installing dependencies, we can run Python save model cache. And now we can start the flow. And the flow is ready. Let's test this flow. This time we will use the VM endpoint and click submit. So it works as expected. Let's quit the flow. And we want to keep this flow running even after we restarting the VM. We can use PM2 to do this. To install the PM2, we need to make sure we have a node environment. We can install the PM2 by typing npm install /g. So we have PM2. Now we run the flow again. Start sh. We can monitor the logs by type PM2 monitor or PM2 logs, and we can see our flow is ready to serve. We can check process. So if we want to stop the flow, we can type PM2 stop. I will keep it running. I will save the list. And let's install the PM startup script. We just copy this command. And even we reboot the VM, the flow will start running automatically. This is very important since we are going to save this VM into an image. And we want every VMs booting from this image to have flow run automatically instead of running it manually. Now let's talk a little bit about logging and monitoring. I will introduce the minimal setup to get basic logging and monitoring by leveraging Cloud Logging API and Ops Agent. Let's set them up. So first we need to fetch the repo and switch the branch to Cloud Logging. We need to install the new requirements. The only difference is it introduced Cloud Logging SDK. And the flow set up the Cloud Logging during the initialization. I already started flow. Let's test it. First, we submit a correct request. We delete the image URL to mark a wrong request. Now, let's go to Cloud Logging. Let's run the query. Okay, so we can see our generating request log into info and a wrong request with empty URL raise the error. We can also filter this by clicking here. So this is a powerful tool. You can search any fields, and also there's lots of filters to use. Now let's install GPU enabled version of the Ops agent by running the following command. Let's see what it can offers. After installing the Ops agent, we can see more metrics such as memory utilization. But the most important metrics for us is probably the GPU usage. So we can go to the Google Cloud Monitoring dashboard, and we can create our dashboard by search GPU monitoring, and we import this dashboard. I have already created this dashboard. Let's see what it looks like. So it will list GPU used in this project. You will see the GPU memory usage in the chart, and also the process using the GPU. So this will be useful after you have more and more instances with GPU. That's all about Cloud Logging API and Ops Agent. Recently, Jina supports Open Telemetry. We could export detailed metrics and logins to anywhere. I talked with engineers from Jina and draw a chart to help you understand what's happening. So you have a AI service using Jina framework, and the Jina framework supports a Open Telemetry exporter. And as developers, we need to set up a telemetry data collector in this yellow square. So this is open source. We can find on GitHub, and it also comes with a lot of exporters. So if we are using Google Cloud, we can install the collector with Google Cloud Exporter, and all the data will be sent to Google Cloud login, trace, and monitoring. If we want to see our telemetry data in Sentry, we can use the Sentry exporter. I won't demonstrate this, but if you are interested, you can try it by yourself. It's pretty straightforward. The only thing you need to set up is the yellow parts here. You can click these links in the slides. They will be helpful when you're setting up the OpenTelemetry. Now we have a functional flow running in a single VM, and we know how to view its logging and metrics. We don't want production requests hit our test VM, It's time to make it production ready. To achieve this, we can set up a VM template and an instance group to handle incoming requests. We will shut down the VM and create a disk image. We stop the instance. Then we go to Storage, Images, and we click Create Image. We name the image Flow Demo v1 and choose our source from disk, and our source disk is our instance. Then we can just click Create to create the image. It will take a few minutes to finish creating this image. We can go to Instance Template and choose Create an Instance Template. We will name our instance templates Demo Template v1, and we choose our GPU to T4, and we change our machine type to have 7.5 gigabytes memory. We change our boot disk. This time we choose Custom Images. So this template will use the image we just created. And we choose Advanced Options, Networking, and we add our networking tags to allow HTTP. So the incoming HTTP requests on port 8088 will be allowed. So everything is set up. We click the Create. We have a Flow Demo template. We can go to Instance Group. We create Instance Group, and we will use our template we just created. We'll keep other settings as default. So it will take a while to create the instance group. Okay, let's refresh the page. And the instance group is created. We can see the VM is starting. And now our VM is running. We can copy the VM IP and test it. Okay, so we replace the server IP. We click Submit. And we can see the result here. The VM is working. And remember, we can still view the cloud logins. We can see our logins for this instance in the instance group. If we have more instances, we can also filter them out. Now let's make this instance group autoscales when there are more requests coming. So I already set it up.
I can show you how I set it up. In auto-scaling signals, we choose cloud monitoring metric, and we choose time series per instance. So it will auto-scale based on instance metrics. And we choose GPU, the GPU utilization. We will set utilization to 50, and we can save this. Now we are going to create a cloud load balancer, which help us to allocate different requests to different instances. We are going to create a HTTP load balancer, and we can continue. We will use the port 8080. Then we are going to set up a backend. So I already create one, but I will show it again. We click create a backend service, and we are going to use name demo, and our protocol is HTTP, and we choose our backend as our instance group. Then we have a port number. And our balance mode is utilization. This utilization is the metrics we set in the instance group. So we can set the balance utilization to also 50. And we save it. We don't need cloud CDN. And we need to set up the health check. If you don't have one, you can create a health check by clicking here. And we can type our name. And the port should be the flow is running. So it will send requests to our flow once a few seconds to make sure our flow is up and running. And we click save to save this health check and use it here. And we can click create to create this backend service. After everything set up, we just choose this backend service. And we click create to create this load balancer. So I already created one load balancer. Here we can see its configuration. And the auto-scaling utilization is 50, and our max backend utilization is 50. So once the load balancer see the utilization is above 50, it will try to allocate a request to another instance. And as you may notice, this already have 4 instances. This is because I have started a load testing for a while. So I have 4 concurrent requests to hit our load balancer. You can see it's still requesting. So if we go to our instance group and see the monitoring, we can see the instance autoscales as the utilization goes up. It scales from 1 to 4. And if we go to the cloud GPU monitoring, we can see we have already 4 GPUs here, and they are all kept at the utilization about 50. So let's change the time to 1 hour. We can see it's adding more instance to the instance group. It's from 1 instance to 4. After I stop the load testing,
the instance utilization goes to 0 and the instance stop. So one thing I should point out, the GPU utilization and GPU memory usage here are not optimized. That's because I set the replica to 1 and also the flow prefetch to 1, which means each flow only handles one request at a time. If we want to increase its utilization, we probably could increase the prefetch to 2 or more. Also, we can increase the replicas to 2. But remember, you may need to increase the VM's memory settings to allow more models to load, and you should avoid too many inference requests running at the same time, which may result in high latency. So now we have covered all the steps to deploy and scale for production. There are some questions I would like to answer before we end. So first, how to upgrade the service in a reliable and efficient manner. Basically, update the VM and save into a new image, and we create it into a new VM template, which we can use to update our instance group. The GCP will help us replace all the instance in the instance group. And for a more efficient and reliable upgrade, I highly recommend automating these steps using scripts and the Google Cloud SDK. In this way, we can run the scripts to perform all the steps we used to clicks before, and we can even perform an end-to-end testing on the new template before we apply it to our instance group. And how to reduce the cloud GPU cost. While this guide provides a production-ready services, it may not be the most efficient in GPU-intensive scenarios. My suggestion is you need to do more load testing and tweak your best configuration. Later, you may need to design and build your load balancer, task dispatcher, and scaling metrics to create a more efficient system. For example, instead of measuring the GPU utilization, at OpenArt we calculate the request computing score to estimate the workload of a request with different parameters. And we also build our instance request dispatcher and message queue to help complex use cases. So today we walk through a simple Jina flow on Google Cloud VM. We also set up Google Cloud logins and metrics. We deploy the service into an instance group and make it auto-scales based on GPU metrics. I hope you get better understanding of this topic. So that's all for today. Thank you all for listening this talk. Huge thanks to Jina for letting me to be a part of the event today. Bye bye.